morning, students. In continuation of the topic electrostatics, we want to quickly answer some questions, some past questions in WAEC. Okay? Now, the first question, we have something like this. We have something like this. We have something like this. Two balloons are rubbed with a cloth and suspended freely. Now the question is this: why is the rope not vertical? This is the rope of this balloon. And then the second question: if the balloons are negatively charged, what will be the charge of the cloth? Now, we have two balloons like this. Both of them have been charged by contact, and they are both negatively charged. Now, when suspended freely, it is observed that they separate. So the question is, why is the rope not vertical? Why are they not standing straight this way? Why are both of them not standing straight this way, side by side? The answer is because both of them have the same charge. That is why they repel each other. Like charges repel, while unlike charges attract. The second question, if the balloons are negatively charged, what will be the charge of the cloth? If the balloons are negatively charged, it means that the cloth that rubbed this balloon will be positively charged. Why? For the balloon to become negatively charged, it must have taken electrons from the cloth. Now, because the balloon have more electrons than proton, it becomes negatively charged. Now, the cloth loses electron. Because it has more proton and electrons, it becomes positively charged. I want to look at another question. We have stream of water. Say the diagram above. In the diagram above, a negatively charged rod is brought close to a stream of slow-flowing water. Explain why the water is attracted to the rod. You turn on the tap and then the water comes out slowly. And we bring a negatively charged rod and bring close to the water. We notice that we observe that the water will be attracted to the rod. So the question is, why? Don't forget, the rod itself is negatively charged. The water is neutral. When we say neutral, it means that the number of positive charges and the number of negative charges are the same. Now, when a charged body, a negatively charged body, is brought close to a neutral body, what is going to happen is this. This negative charge will repel all the negative charges in this body down to this extreme end and then attract the positive charges close to itself. That is what is happening here. The positive charges move towards the side of the negative charge, while the negative charges in the water are repelled backward. For that reason, negative and positive attract each other. That is why it's as if the water is attracted to the charged rod. The last question. Okay. Now we have something like this. This is a candlestick with a flame on it. This is the question. And then we bring a rod. It said, in the diagram, a negatively charged rod. This is negatively charged rod. Is brought close to a candle flame. The flame became hazy. Explain this observation. When we have a candle flame, this is a candle. And this is the flame on that candle. When we bring as initially the flame will burn normally. Okay. When we bring a negatively charged rod close to it, we find that it becomes hazy. They are asking a question: why is it hazy? Why this observation? It is like this: when the candle flame burns, it will ionize the air around it. Ionization means the atoms there emits electron, releases electrons. So what we have is negative electrons and positively charged ions. Now, when we bring a negative charge rod close to the candle flame, what the negative charge rod will do is this: it is going to repel all the electrons which are negatively charged and then attract all the positively charged ions. For that reason, it is going to become easy. Thank you very much. In the Google class, we're going to be looking at this the more. Thank you.